Good afternoon, students. Today onwards, we are going to our 11th standard syllabus. I don't know how many of you have a textbook. Even in not having textbook, there is no problem. Listen carefully, take notes. If you are having notes, if you are take notes, when I am teaching, you can understood clearly. Okay? Okay, students. Today, we are going to start from unit number 2. Okay, second unit onwards, we are going to study. What is the unit number 2? Quantum mechanical model of atom. Quantum mechanical model of atom. In this unit, whatever topics you are going to study, first, introduction about the atom and different atomic models and wave particles, angular momentum, de Broglie concept, Heisenberg uncertainty principle, Schrödinger equation, quantum numbers, shape of atomic orbitals, energies of orbitals, electron filling of orbitals, and so on. Okay. Today we are going to study about introduction about atom, Bohr atom model, Rutherford atomic model, and applications and then limitations. Listen carefully, students. Okay. Introduction to atom model. Introduction to atom model. All things are made up of matter. You know, all things are made up of matter. What do you mean by matter? Matter means everything you see around yourself having weight and occupy space is called matter. Okay, matter means everything you see around yourself having weight, anyone having weight, anyone having occupy space, that is called matter. What made up of matter? What made up of matter? Matter made up of a basic unit is called atom. Okay, no, you know clearly about atom. Last week we well thoroughly about atom, about protons, about neutrons, and how electrons are revolving around the nucleus. What are nucleons? We clearly studied about that. I hope all of you know about that. Okay, so it is very easy to study this lesson. Okay, whoever do experiment about atom. First upon J.J. Thomson experiment. J.J. Thomson experiment. J.J. Thomson did the cathode ray experiment. Cathode ray experiment. From his experiment, we revealed that the atoms consist of negatively charged particles called negatively charged particles. What? You know, electrons. Okay. And also he proposed that atom is a positively charged sphere in which the electrons are embedded like seeds in the watermelon. Okay. He didn't tell about how electrons filling, how electrons revolving around, and how electrons are revolving around the nucleus. What about orbit? What about orbitals? He didn't tell about that. Okay, only he told that the atom has positively, negatively charged particles called electron, and the positively charged uh, sphere. That only he said. Okay, so it is the limitations about the J.J. Thomson experiment. Okay, after that, the Rutherford alpha ray experiment. Rutherford, one of the scientists, Rutherford, he did the alpha ray experiment. Alpha ray scattering experiment. What is alpha ray scattering experiment? He take one of the thin gold foil and he bombarded a thin gold foil with a stream of fast moving alpha particles. Stream of fast fast moving alpha particles. Okay, what is he observed? Whatever points he observed. He observed that most of the alpha particles passed through the foil. Most of the alpha particles passed through the foil. Secondly, some of them were deflected through a small angle. Some of them were deflected through a small angle. And thirdly, very few alpha particles were reflected back by 180 degree. Very few alpha particles were reflected back by 180 degree. Okay, students, whatever observations having, most of the alpha particles passed through the foil. Some of them were deflected through a small angle, and very few alpha particles were reflected back by 180 degree. Okay, he take the gold foil, thin gold foil, and a stream of alpha ray particles, fast moving alpha ray particles, he passed through the gold foil. Whatever observation he find out, most of the alpha particle passed through the foil. What he proposed about that most of the alpha particle is passed through the foil? From this, what he find out? The atoms has empty space, large empty space. Okay, atoms has large empty space. Okay, because of the empty space, the alpha particles move fast. Okay, alpha particles can move fast. Okay, the atom has large empty space. Because of the empty space, okay, in the empty space, the alpha particles move fast. Okay, and second, some of them were deflected through a small angle. Some of them were reflected through a small angle. Some of them reflected back. Because of the electrons are moving continuously around the nucleus in the empty space. Okay, but through the empty space, the electrons are revolving around the nucleus. Because of that, some were deflected through a small angle. Okay, and thirdly, very few alpha particles were reflected back by 180 degree. Very few alpha particles were reflected back by 180 degree. What he concluded that? What he find out from that? The atom has small, tiny, positively charged nucleus. Atom has tiny, positively charged nucleus. Because of the nucleus, when he passed through the alpha particles, because of the nucleus, these alpha particles cannot go fast. Okay, so this alpha particle reflected back 180 degree. Okay, understand? Okay, from this from his experiment, whatever things he proposed, first point, atoms has tiny positively charged nucleus, and around the nucleus has empty space. In this empty space, electrons are revolving around the nucleus with high speed. In this empty space, electrons are revolving around the nucleus with high speed. Okay. When electrons moving continuously around the nucleus, it lose energy in the form of radiation. When electrons moving continuously around the nucleus, it lose its energy in the form of radiation. Okay, with high speed, when electrons revolving around the nucleus finally collide with the nucleus, resulting in the collapse of atoms. This is the nucleus. Okay, this is the orbits. The electrons revolving around the nucleus in the orbit. In orbit, okay. And these electrons, when revolving around, okay, it can lose energy. It can lose energy. It can lose energy, okay, in the form of radiation. And because of attractive force between the nucleus and the electrons, nucleus, the positive charge nucleus and the negatively charged electrons, it can move fastly through the entirely orbit, and finally it collide the nucleus. It comes closer to the nucleus. Finally, it collide the nucleus and resulting in the collapse of the atom. Okay, and resulting in the collapse of the atom. These are the conclusion about Rutherford model. Let me repeat. Rutherford did the alpha ray scattering experiment with thin gold foil. He take one of the thin gold foil when a stream of fast moving alpha particles. What are the observation he find out? Most of the alpha particles pass through the foil. Some of them were deflected through small angle. Very few alpha particles were reflected back by 180 degree. What are conclusions he find out? The atoms has tiny positively charged nucleus, then only the alpha particles are reflected back. Okay. And secondly, around the nucleus has empty space. Because of the empty space, the alpha particles move fastly. Okay. And third one, the electrons are revolving around the nucleus with high speed. And fourth point, when electrons moving continuously around the nucleus, it lose energy in the form of radiation. With high speed, when electrons revolving around the nucleus finally collide with the nucleus, resulting in the collapse of the atom. Okay, understand? These are the Rutherford experiment. Whatever limitations from the Rutherford experiment, Okay. First upon, Rutherford does not explain how electrons are distributed around the nucleus. Rutherford told that the atom has tiny positively charged nucleus and electron revolving around the nucleus, and he did not tell about how the electrons distributed around the nucleus. About that he didn't tell. Okay. And he does not explain the stability of an atom. He told that with high speed, electrons revolving around the nucleus finally collide with the nucleus. When it move fast and around the nucleus and come closer to the nucleus, and it collapse the nucleus, and finally it collapse the atom. Okay. So he does not explain the stability of an atom. This is the one of the limitation, very important limitation of the Rutherford. Okay. Due to this limitation, another one scientist, the student of Rutherford, who is Niels Bohr, provide another one model. That is called Bohr atom model. Okay. What about Bohr atom model? Bohr atom model means this is one of the new atomic model for the hydrogen atom. He explained about hydrogen atom. Okay, hydrogen like atom. Okay, the Neil and Bohr explained about the hydrogen like atoms. Okay, hydrogen like atoms. He proposed that when atom has positively charged nucleus, also here find out this, and when electrons revolving around the nucleus, in a circular path, when it is revolving around the nucleus, it lost energies. Okay, it lost energies. Okay, and what are the assumptions? What are the assumptions of Bohr atom model? What are the assumptions? Very, very important. What are the assumptions of Bohr atom model? When electrons revolving around the nucleus, it lose energy in the form of radiation. Okay. So what are the first point means? What are the main assumptions about Bohr atom model? The energies of electrons are quantized. The energies of electrons are quantized. What do you mean by quantized? The energy of electrons are measured. Okay, that is h nu. That unit is called h nu. H means Planck's constant, you know. Nu means frequency of radiation. Okay. And what is the second assumption? The electrons is revolving around the nucleus in a fixed circular path called stationary orbit. The electrons is revolving around the nucleus in a fixed circular path that is called stationary orbit. Okay, what do you mean by stationary orbit? Stationary means a fixed orbit. That means the electrons only around its own orbit, not entering the other orbit. But it gain any external energy. When we are giving any external energy by heating or any other external energy we are giving, it can jump from one orbit to another orbit. Okay, but when circulating the atom, it can lose the energy. And it come closer to the nucleus. Okay, and what are the third assumption? What a third assumption means? The electrons can revolve only in those orbits in which the angular momentum of an electrons can revolve only in the orbit in which the angular momentum of an electron can revolve only in orbit in which the angular momentum of an electron. What do you mean by angular momentum? Angular momentum means the tendency of electrons to continuously rotate. Okay, the tendency of electrons to continuously rotate. Okay, The electron can revolve only in the orbit in which the angular momentum of an electron, that is called MVR. Angular momentum is MVR. Here, what do you mean by R? Means radius of nth orbit. A radius of nth. What do you mean by nth orbit? You know about orbit. Orbit means K orbit, L orbit, M orbit. Okay, we indicate N. This orbit we indicate by N. You know about that. Okay, R means radius of nth orbit, and V means velocity of electrons, and M means mass of electrons. Okay, and then this MVR is equal to integral multiple of h by 2 pi. This MVR is equal to integral multiple of h by 2 pi. What do you mean by integral multiple? Integral multiple means this is the orbit. This indicates the orbit. Nth orbit. Okay. How many orbits are there? We studied about 4 orbit, K orbit, K, L, M, N. Okay. But here so many orbits are there. Okay. When atomic number increases, and you know about atomic number, what do you mean by atomic number? Means number of protons or number of electrons. Okay. So atomic number increases, number of electrons also increase, you know. Okay. And atomic number increasing, when atomic number increases, number of orbit also increased. Okay, or number of orbits also increased. Okay, for example, hydrogen atom only one orbit is there, but calcium atom means atomic number 20, number of electrons 20. How many orbits are there? 4 orbits are there. How electrons are filling in orbit? 2, 8, 8, 1. 8, 2. Okay, these are the about the calcium. Okay, so now atomic number increase, the number of orbits also increase. In the case of xenon 54, you know how electrons are filling. 2, 8, 18, 18, 8. How many orbits are there? 1, 2, 3, 4, 5 orbits. Okay, how we can indicate K, L, M, N, O. Okay, so atomic number increases, number of orbits also increased. Okay, so the MVR is equal to integral multiple of h by 2 pi. Integral multiple means n. Okay, so MVR is equal to n h by 2 pi. N means integral multiple. Okay, understand? And then fourth point. What about fourth point? When electron revolve in fixed stationary orbit, when electron revolves in fixed stationary orbit, it does not lose its energy, but when electron jumps from higher energy state to lower energy state. Here, when electrons revolving in fixed stationary orbit, it does not lose its energy. Okay, electrons revolve in fixed stationary orbit, it does not lose energy. But when electrons jumps from higher energy state to lower energy, because it continuously loss energies it can jump from higher energy to lower energy. What do you mean by higher energy, lower energy? What do you mean? Here, listen here. This is the positive charge nucleus and this is the orbit. First, second, third, fourth. Okay. So here, this is the lower energy. This is the lower energy orbit. E1. This is the E2. This is the E3. This is the E4 orbit. Okay. This is the lower energy. Okay. When electrons revolving around very closer to the nucleus, that is called a lower energy orbit. Okay. So it is so away to the nucleus, that is higher energy level. The electrons revolving around the nucleus, it is so away, that is higher energy orbit. Okay. So when electrons revolving in fixed circular orbit does not lose its energy, but when electrons jumps from higher to lower. Okay, suppose we are giving any external force or energy, it can jump from lower to higher and higher to lower. Okay, when electrons revolve in a fixed circular path, it does not lose its energy. But when electron jumps from higher energy state to lower energy state, there is E2 minus E1. E2 means higher energy, E1 means lower energy. There is equal to H nu. Okay, it is the energy will be quantized. Okay, that is E2 minus E1 is equal to H nu. It is depending upon the Planck's and Einstein law. This assumption depending upon the Planck's and Einstein law. Okay. So here, what is the frequency of emitted radiation? The energy we measured. Okay. From this energy, how we measure the frequency of the emitted radiation? How measure the frequency of the emitted radiation? The frequency nu is equal to E2 minus E1 by H. Okay, H is the Planck constant we know about. H is equal to, what is the value of Planck constant? 6.626 into 10 power minus 34 joule second. Joule second is the unit of Planck constant. Okay, understand? And what is the last point? If suitable energy is supplied, if suitable energy is supplied to an electron, it jumps from lower energy orbit to a higher energy orbit. Okay, understand? If suitable energy is supplied to an atom, it jumps from lower energy orbit to a higher energy orbit. Okay, understand, students? Listen carefully. The electrons, when we are giving some external energy, the electrons can jump from lower to higher. Okay, so when the electrons are jump from lower to higher, you should provide energy, otherwise they cannot jump. Okay, so the electrons want to move from higher energy to lower to higher energy, it need energy. But in the case of the electron jump from higher to lower, it releases so much energy. That is called radiation. Okay, understand? That is main assumptions of Bohr Atomic Model. Okay, this is the main assumptions of Bohr Atomic Model. Let me repeat. Whatever assumptions, there are 5 assumptions are there. What are they? First upon, the atom, the energies of electrons are quantized. The energies of electrons are quantized. Second, the electrons is revolving around the nucleus in a fixed circular path is called stationary orbit. The electrons can revolve. What is the third point? The electrons can revolve only in those orbits in which the angular momentum, that is angular momentum is equal to mvr. Here the angular momentum mvr is equal to integral multiple of h by 2 pi. mvr is equal to nh by 2 pi. Okay, understand? And what is the fourth point? When electron revolves in a fixed circular orbit, it does not lose its energy, but when electron jump from higher energy state to lower energy, the energy is quantized. Okay, the E2 minus E1 is equal to h nu. The energy is quantized. Okay, and what is the fifth point? When if suitable energy is supplied to an electron, it jump from lower energy orbit to a higher energy orbit. Okay, understand, students? And what are the applications of Bohr's postulates? What are the applications of Bohr's postulates? What are the applications according to Bohr's postulates? The radius and energy of hydrogen-like atom, that is means one electron species were derived. Okay, the radius and energy of one electron species were derived. That is organ. Organ means the radius of nth orbit. Radius of nth orbit is equal to 0.529 by into n square by z. Z is the atomic number Armstrong. Okay, and En means energy of nth orbit minus 13.6 z square by n square electron volt per atom. Okay, and then En or En is equal to minus 1312 plus 8.8 is z square by n square kilojoule per mole. Okay, and then what are the limitations of Bohr's atomic model? Here also having the limitations. Okay, here are also having the limitations. This is only whatever having the about the detailed derivations about Rn and En will be discussed in 12th standard atomic physics units. Okay, and what are the limitations of Bohr's atomic model? Whatever limitations are there, first upon, it is applicable only to only one electron, only one species having one electron. Okay, one electron. And then secondly, it was unable to explain the splitting of spectral line in the magnetic field or electric field. It was unable to explain the splitting of spectral line. What do you mean by spectral line? Dark or bright line by emission of or absorption of light. When emitting or absorption of light, the atoms can give the spectral lines. Okay, split the lines, the dark or brown lines. Okay, it cannot be find out the spectral lines when in the magnetic field or electric field. Okay, it was unable to explain the splitting of spectral lines when we are applying magnetic field or electric field. Okay, understand? So what is the limitations of this? Because of this, we cannot find out we cannot identify the atoms or molecule. Okay, these are the limitations of Bohr's atomic model. Limitations of Bohr's atomic model. It is unable to explain by the electrons is restricted to revolve around the nucleus in a fixed orbit, in which the angular momentum of electron is equal to nh by 2 pi. Okay, so it is explained by Louis de Broglie. Okay, next class we can see about that. Okay, so today's assignment first, explain the observation and conclusion of Rutherford's alpha ray scattering experiment. Second, explain assumptions of Bohr atom model. These two questions very important. Student should study. Please study and write and answer. You should send me through WhatsApp. Okay, understand? Okay, thank you.